Welcome to the fresh, clean world of hydroponics, an exciting concept for growing nutritious salads, vegetables, herbs, and flowers. Come with us on a video voyage and discover how to provide your family with a clean, tasty, and healthy diet, grown on waist-high tables with no weeding. The program will also explain larger commercial installations, which will give you the full picture, allowing you to draw out the information which will best suit your specific interests and needs. So now enjoy the world of hydroponic growing, and here's Grant to explain the first essential requirement, suitable water.
Let's have a look at the basics of hydroponics, how it works, and some essential things to know before beginning any type of hydroponic growing. Now, the first basic rule is our water quality. Hydroponics simply means to work with water, and since water is such a large component of hydroponics, we need to ensure that it is suitable to grow plants in. All water supplies are different. They may look the same, even taste the same, but it's the elements that dissolve into water that can cause serious problems. Let's have a look at some different water supplies and see how pure water does not conduct electricity. Here we have a sample of pure water, and when we immerse this meter, we are measuring the conductivity or the amount of salt that has been dissolved into the water. In pure water, the reading is 0. This means it contains no salts. Next, we have a sample of town drinking water, and this gives us a reading of 2. This means that there is something in the water, however, at this point, we don't know exactly what. Now let's look at a third sample, river water. You'll see this gives us a reading of 10. So obviously these three water samples, which appear the same, are actually all different. Let's find out why. Well, we need to start at the water source. One of the greatest solvents around is water. As rain falls through the atmosphere, it can collect various contaminants from air pollutants. Acid rain in Europe, for instance. Once rain hits the ground, it can easily pick up elements such as iron, zinc, and copper. If it runs across a paddock, it may absorb elements from soil fertilizers. Then it may run into rivers and pick up other contaminants. If rain seeps down through soil and rock to a deep water table and is later brought back up to the surface from a bore, the chances are it has absorbed so much salt it is now unsuitable. As a general guide, all town water supplies are great for use in hydroponics. If, however, you are not on town water or a commercial grower pulling water from a dam or bore, you'll need to have an analysis done to ensure suitability for use in hydroponics. Nutrient manufacturers spend a considerable amount of time ensuring that formulas provided are in correct balance for plant growth. Now, if we were to use untested water supplies, which may have dissolved contaminants already in it, and then add our nutrient on top, we may find, for example, the small amount of zinc provided in the nutrient is already present in the water. So then we have twice as much zinc than we need, which will eventually cause toxic buildups. This will severely stress and reduce the yield of your plants, and if not rectified, will eventually kill them. A few tips when considering the use of piping fixtures and tanks. There are only a few safe products to use in hydroponics for the carrying or holding of water. Best examples are virgin plastic, stainless steel. Any other products such as reground plastics, galvanized piping or tanks, copper or brass plumbing fittings are totally unacceptable. Even concrete tanks can react with the nutrient by way of a leaching effect. Have a look at this copper piping with the blue crusting powder-like substance growing on it. Or remember how on a very hot day you take a drink out of the hose and the water tastes like plastic. This is the type of contamination we're talking about, and it must be avoided at all costs. If you're unsure, talk to your supplier. Today, in many cases, technology can solve poor water quality problems. Always remember, if your water is not right, then nothing else in the system will be right.
quality of water leads us to our next subject.
Let's talk about oxygen. Now, oxygen is absolutely essential around the plant's roots. If we don't have it, we're going to get into all sorts of problems. We're going to get cell death, we're going to get diseases in, we're going to be in all sorts of strife. Now, if you've ever seen a stagnant pond, this is a classic example where we've got water with no oxygen in it. We've got a smelly water, we've got dead vegetation all around, nothing is happening. And the reason for this is that the plants have taken all the oxygen out of the water, but there's been no way of reintroducing it. In a hydroponic system, we must reintroduce it. On a recycling system like this, it's very, very easy. All we've got to do is allow our nutrient to spill back into the tank. This, in turn, creates bubbles down into the water, the oxygen is redissolved in, and our problems are solved. If we're in a commercial situation or we want to do something a little bit more sophisticated, all we have to use is an instrument like this. It's called a spa pool venturi, and it simply uses pump pressure to create a vacuum, sucks air down and allows lots and lots of fresh bubbles of oxygen into our tank.
Plants discharge waste gases from the root zone. These heavy gases flow back with the nutrient solution, and if allowed to be reabsorbed at the tank, can almost put plants to sleep. The venturi sucks fresh air from outside the tank area, which bubbles up through the nutrient, redissolving fresh oxygen. The rising bubbles help push the gases away from the tank. An extractor fan can be very helpful.
Now let's have a look up on top of the bench and see how we make sure the oxygen is correct in the actual gully itself. Now you don't get lettuce as good as this unless you know what you're doing. Look at these beautiful healthy roots. 1 millimetre of nutrient on the base of the channel, good airflow coming in around the top. Capillary action draws the moisture up into the roots so they're not drowned, and look what we get, beautiful roots like this, a perfect environment for your plants. Now let's go and have a look how long we can make these channels. For lettuce and plants of a similar size, we can run our gullies as much as 18 metres long. However, for something that needs a lot more oxygen around its roots, like a tomato, cucumber, 12 metres is a pretty good guide. It's fairly easy to see on an NFT system where the actual point of oxygen runs out as well. In hydroponics, because everything is so perfect, all our plants grow basically the same size, the same height. Now on the gully, all of a sudden you'll see this beautiful even amount, and then all of a sudden it's going to start to drop off. Now the point where that plant size starts to drop off is where the oxygen's run out. It's not the food. A lot of people think that, but it's where the oxygen runs out. So all this trouble that we've gone to with our spill back into the tank, with our venturi, with our right flow rate, remember maximum 1 litre per minute, is to make sure that we've got good oxygen in that 1 millimetre thick film of water underneath the plant's roots. Without that, the system's not going to work. It's so easy to do, you've just got to make sure that it's happening correctly. To get oxygen into a flood and drain system, let's use a simple demonstration. Here we have some expanded clay, and what we're going to do is we're going to pour water in. Now, as you'll see the water level rising, what's actually happening is the water is filling up all the cavities and pushing all the stale air out. Now, to get the oxygen back in, all we have to do is drain it from the bottom. The water level will drop, air will be sucked back into the media, and we've got a beautiful moist situation for our plants once again. Exactly what we were looking for in the NFT, but this time we're using media. We don't want it too wet, we just want it moist. Another kind of media we have available is called rock wool. Now, rock wool is made from basalt rock. What they do is they heat the rock up to very high temperatures and then they spin it, very similar to fairy floss. What we do here is we drip irrigate. We actually pour the nutrient on from the top, but the same principle applies. As the nutrient fills the rock wool, the stale air is pushed out. The rock wool itself will then find its own ratio of air and water, so the water will drain away, leaving the slab or the cube moist. Exactly the same principle, just a different way of doing it. Now, there are a few other medias available. Here we have what's called perlite. Now, perlite, again, is a heated rock. It's very, very light. It holds lots of air, but it holds moisture as well. And Another one that you might already know around the garden is called vermiculite. Now, vermiculite will hold a lot of water. If you mix 2 parts of perlite, 1 part of vermiculite, you'll find a pretty good hydroponic media mix. That mix will hold the right amount of air and the right amount of water to keep sufficient oxygen to your plant's roots so that your system will work properly. One little problem that you do find is that these materials, if you forget to water them, are very, very light. So sometimes you might want to move to a more heavy material, like Versarock here. It just has a little bit more weight in it. So if you're going to put a little hydroponic plant out on a balcony or a railing or something like that where there's a bit of wind, you'd better go for something a little bit heavier in media.
Here is a simple flood and drain system. The pump is immersed in the nutrient tank located under the main tray. We then pour the expanded clay media into the tray. Expanded clay is ideal for use in hydroponics and is quite decorative. Evenly spread it across the surface in readiness for the seedlings, which can be either in grow pots or, preferably, with bare roots for larger plants. Allow ample space between your seedlings so that overcrowding does not occur when fully grown. The pump now begins its cycle. Watch closely as the bubbles of stale air are pushed out by the rising nutrient. The white pipe drains excess nutrient back to the tank and prevents overflow from the tray.
By using this scaled-down NFT method, successful growing can be achieved at home. Here's Trish to demonstrate the ease of setting up a domestic unit. In this demonstration, she's using the Hydroponic salad table. Your local hydroponic dealer should be able to show you a similar locally made product. It takes only 10 minutes to set up this Hydroponic table, and its portability allows you to move it later if necessary. Simply place the unit near a window or a skylight or on your balcony in the appropriate season. The table is made of maintenance-free, strong PVC, and once hooked up can operate unattended for about 10 days. The water feed to the gullies is snapped into place, the tomato rail is fitted, and we're about ready to add the nutrient and water to the tank. Now push the 2 water feed pipes into the gully and add the measured liquid nutrient. The small submersible pump has already been placed at the bottom of the tank, and the table is sealed so there are no leaks. Add the water, bringing it close to the rim, and make sure everything is hooked up and ready to go. Turn on the power and you're up and running. It's as simple as that. Once everything has been set up, you're ready for the exciting moment, planting the seedlings. Place them in your grow cups, add the media, and insert the cups into the table. Instantly, the media takes up the nutrient flow, and the grow cycle has commenced. It's now midwinter with the room temperature at a comfortable setting. With the table placed near a window, we can observe this amazing out-of-season growth pattern of a variety of plants. Fast-growing lettuce and herbs are replaced every few weeks. You can simply pick from the table as required. Later, we'll show you the results of this sequence. In the meantime, here's Grant to talk to you about the nutrient formula.
The nutrient solution that you use in your system is made up of all of these elements: nitrogen, phosphorus, potassium, sulfur, calcium, magnesium being the macro elements, and iron, manganese, boron, copper, zinc, and molybdenum being the micro elements. Now, in order to get all of this material up into the plant, what we've got to do is we've got to keep our pH correct. Now, pH is the measurement of how alkaline or how acid the solution might be. And what we're trying to do in our system is keep it between 6 and 6.5. And the reason for this is if it's too high or too low, certain elements aren't available to the plant. And these bands crossing here that do look like rocket ships are trying to explain that to us. If we have a nutrient solution at a pH of 5, the small part of the bands here represents the availability of that element to the plant at that